Hey, Miss Teasley here. Today I want to talk about properties of logarithms. And so if you remember from the previous section, we talked about logarithms. Logarithms are exponents. All right, so just another way of writing exponents. So therefore, they follow the same rules as exponents. So let's take a look here. So we have this table where we're going to have our list of all of our properties of logarithms. So the first property is a product property. Log base a of x times y is equivalent to log base a of x plus log base a of y. All right. So just think about if you had an exponential form, if I had a to the x power times a to the y power, to get my final answer, I would add exponents. So that's how that relates. So over here, the description, the logarithm of the product of two numbers is equal to the sum of the logarithms of the numbers. Quotient property, well, think about quotient. If you had a to the x over a to the y, you will subtract exponents. So here, log base a of x over y becomes log base a of x minus log base a of y. So the logarithm of the quotient of two numbers is equal to the difference between the logarithms of the numbers. And then you have the power property. So remember, if you have something like a to the x power and you're raising it to the y power. Well, when you raise a power to a power, you multiply. So this is a to the x, y. So if you look over here, this log base a of x, remember that's an exponent in itself. And then you have that raised to the r power. So you're multiplying. So what we do is we take that exponent and we bring it right in front and it becomes the coefficient. So log base a of x raised to the r power, the r comes right in the front. And so you're multiplying r times log base a of x. So the logarithm of a number raised to a power is equal to the exponent multiplied by the logarithm of the number. All right, and then you have the property log base a of 1 equals 0. All right, the base a logarithm of 1 is always going to be 0. So basically, any base raised to 0 equals 1. So that's the exponential equivalent to that. And then log base a of a equals 1. So the base a logarithm of a is 1. So a raised to the first power equals a. All right. So here in the first example, we're going to be expanding. So when you see this in your assignments, you'll see the word expand the logarithm. So expand. So when I expand, I'm going to be writing the word logarithm multiple times. So for the first example, I have log base 6 of 12 over 5. Well, this is the quotient rule. This is equivalent to log base 6 of 12 minus log base 6 of the denominator, which is 5. And that's exactly how you write it. That would be your final answer. That quotient becomes a difference. For part B, log base a, and then you have the fifth root of r to the third power. Well, first thing is you want to rewrite this radical, which is that root stuff, in exponential form or exponent form. So really what you have is log base a of r. R is raised to the third power. The fifth root means that I'm dividing that exponent by 5. So that's how I rewrite it. And then to expand the logarithm, the exponent that we have, which is the 3 over 5, we bring it right to the front. So I take that 3 over 5, bring it in front of the word logarithm, it becomes a coefficient. So in expanded form, this is 3 over 5 times log base a of r. All right. Moving on to part C. So C is similar to part B. First thing I want to do is want to rewrite this using exponents. So I don't want to write it as a cube root of 9. I'm going to rewrite this as log base 2 of 9 to the 1 over 3 power. So cube root is raised to the 1/3. And then to simplify this or put it in expanded form, we're bringing the exponent, we're moving it to the front, and it becomes our coefficient. So this becomes 1/3 log base 2 of 9. All right, so part D, you have multiple variables here. First thing you want to do is you want to split all those variables apart. Anything that's at the top of the fraction will be separated by plus signs. Anything at the bottom, meaning the u to the third and v to the fifth, will be separated by minus signs. So always remember, if you look at the first example, that 5 was in the bottom. So notice how it's minus log base 6 of 5. So we're going to use that to help us do part D. So looking at part D, all right, this is going to be expanding a pretty long expression. You have log base b of r plus log base b of s squared plus log base b of t. All three of those variables at the top of the fraction. The u and the v are at the bottom, so I'm going to put minus, because it's at the bottom, a log base b of u to the third minus log base b of v to the fifth. So I broke up everything that was multiplied together. Now the final step is to get rid of any exponents. So you notice you have this s squared, u to the third, and v to the fifth. Those exponents become the coefficient of the logarithm. So this 2 is going to drop right down in front of that log there. So this is log base b of r plus 2 log base b of s plus log base b of t minus the 3 that's here drops right down behind that minus sign in front of the word log. So 3 log base b of u minus the 5 drops down in front of this log. So 5 log base b of v. This is your expanded form of that logarithm. Part E will be a great example where you can stop, pause the video, and try it on your own. And then we'll come back together and look at it. All right, so hopefully you had a chance to try example E. So again, you don't want radicals. You want to write it in exponential form. So before I do anything, I'm going to rewrite this logarithm as log base A. This whole entire fraction, r cubed, s squared, and t to the fourth, is raised to the 1 over m power. So since the index is m, it's 1 over m. So notice when I had cube root above, I wrote 1 over 3. So now I need to expand this. This exponent here, you can bring it right in front of the word log. So it's going to drop down in front. So what I have is 1 over m. And then I have the log base a of this fraction. So r cubed s squared over t to the fourth. Now I need to expand all this stuff. So all this stuff behind the word log, I need to separate. Anything that's at the top of the fraction will be separated by plus signs. Anything at the bottom will have a minus in the front. The 1 over m needs to stay there. So, and it applies to everything that's attached to that log. So I'm going to put a 1 over m, and then I'm going to do parentheses. Log base a of r cubed plus log base a s squared. The t to the fourth is in the bottom, so I'm going to put minus log base a of t to the fourth. The last step is to get rid of all the exponents by bringing them in the front and making them coefficients. So this 3 comes in front of this word log. 2 comes in front of this log, and 4 comes here. So my final step would be 1 over m, 3 log base a of r, plus 2 log base a s, minus 4 log base a of t. And there you have it. I have the expanded form of that logarithm. So now we're going to go backwards. All right, we're going to go from expanded form to what we call condensed form. So this is condensed. So you'll see the word condense the logarithm. So when you're condensing a logarithm, you should see the word log 1 time by the time you finish the problem. So if you think about before, anytime I had a minus sign, that meant that that variable or that term went in the bottom of the fraction. Anything that's positive is going to go to the top. So I notice I have log base 4, so I'm going to write the word log base 4. Draw a fraction bar. At the top of my fraction, I have an x and a z because they both are positive. There's a positive sign in front of that word log. So that xz is going to go side by side at the top of the fraction. Because there's a minus sign in front of log base 4 of y, the y goes in the bottom. And this is your condensed form. So I put that parentheses because, especially when you're putting this into my math lab, you want to make note that that log goes to that entire fractions. So it's a good idea to put it there. All right, looking at part B. All right, well, part B, I have numbers in front of my logarithms. Well, how did those numbers get there? Well, those numbers were exponents originally. So that 4 becomes an exponent for the r variable, and the 5 becomes an exponent for s. So when I write this, this is log base b of r to the 4th minus log base b of s to the 5th power. Now I need to condense it. All right, when I condense it, I want to see the word log written 1 time. Remember, if there's a minus sign, that means that term or that variable goes into the bottom of your fraction. So this is log base b. Draw my fraction bar. The r to the 4th goes to the top because that's a positive log. The one that has a minus in the front, which is s to the 5th power, goes in the bottom. All right, and that's your answer. So part C will be a great example where you can pause the video, stop, and try example C. All right, so part C, we're going to go ahead and condense this logarithm. First thing, any coefficients, you make those exponents. So I'm going to make those an exponent. So this is log base a of x to the 1/3 plus log base a of y to the 2/3 minus log base a of xy. All right, so that's the very first step, is to get rid of the coefficients. Now I want to write this as a fraction. Anything that's positive is going to go at the top of my fraction. So this is log base a, x to the 1/3 and y to the 2/3 goes to the top of the fraction. Because there's a minus sign in front of this last term, that means the x and the y goes below it. And then if you have a fraction that can be simplified, you want to go ahead and simplify that. So I have a xy at the bottom, and I have that x to the 1/3 and y to the 2/3 at the top. So what I'm going to do is I'm going to subtract exponents. Now, if you remember way back, we talked about simplifying rational expressions. You want to subtract exponents, but you always want to subtract the smaller exponent from the bigger. So here, my exponent for x is 1 at the bottom, and then you have a 1 to the 3rd at the top. Well, 1 is bigger. So when I find my simplified version of x, I'm going to do 1 minus 1 over 3. Well, 1 minus 1 over 3 becomes x to the 2 over 3. Because the 1 is bigger, when I write my final answer, it'll be log base a. And then since the 1 is bigger, I'm going to put the x to the 2/3 in the bottom. All right, so here I'm simplifying this. Then same thing for y. I'm going to do 1 minus 2 over 3. This is how you get around negative exponents. 1 is the same thing as 3 over 3. So 3 over 3 minus 2 over 3 is 1 over 3. Again, the 1 is bigger, so that y is going to go to the bottom, 1 over 3. And then you need to put a 1 at the top. There should be, you can't just leave it blank. So 1 is always there. So I put my 1 there as my placeholder. And this is your simplified answer. Now, you have to look at the directions. They may say, write final answers using radical symbols versus leaving it as 2/3 and 1/3. So what I can do is one extra step, and this is only if needed. This is log base a. This is 1 over. They both have a 3, so that's cube root. The x has an exponent of 2, and the y has the exponent of 1. So they will go underneath the radical symbol like that. All right, so either this is your answer, leaving it with rational exponents, or you can write it in radical form. All right, I want to go over one more example in that section because you're going to run into some problems when you're doing your homework. What I'll tell you, if something can be simplified, you need to simplify it first before you condense it. So I'll call this example D. So let's say if I have log base 2 of 4 minus log base 2 of y plus log base 2 of x. All right, so I'm just throwing some examples out. And they asked me to condense. Before you do anything, you want to double check to see if you can simplify any of these logs. So if you notice here, log base 2 of 4, I can simplify log base 2 of 4. What it's asking me is what exponent. So 2 raised to what exponent. So the base 2 raised to what exponent is going to give me a 4 back. And that answer is just 2. That's the simplified version. So log base 2 of 4 is just equals 2. So you'll want to do that first. Minus log base 2y plus log base 2x. And then I can condense this stuff here. So I have a 2, and then I have a minus log, and then this plus log. Because that's a minus, that means the y is going to go in the bottom of my fraction, and then that x has a positive log in front of it, so it's going to be positive. So you put plus log, and then you put base 2. X goes at the top, and y goes at the bottom. All right, so that will be your simplified version. So just watch out for terms like that can be simplified. All right, here, this is a theorem of inverses. So remember, logarithms and exponential functions are inverses of each other. So if you look here, you have this log, this a, which is a base, and then it's raised to log base a of x. Well, that's going to always just give you x. So when these two numbers are the same, it's going to be whatever you have here. So for example, if I have 3 log base 3 of 2x. Well, since I have a 3 here and a 3 there, those just cancel each other out, and my final answer would be 2x, is whatever's here. Then you have log base a of a to the x equals x. All right, so let's talk about that. So log base a of a to the x equals x. Well, let's look at an example. So what if I have log base 2 of 2 to the x? Well, if you look at this, you can expand this by bringing x to the front. And so then you have x log base 2 of 2. Well, what is log base 2 of 2? 2 raised to what power is going to give me a 2 back? Well, that answer is 1. So what's in this box is just 1. And x times 1 equals x. So that's how that works. So basically, whenever you see log base A, and then what you have beside it is a base of another exponent, they cancel each other out as such, and then you're just left with whatever's here. All right, x. All right, so just a property you may run into. Then you have common logarithms and natural logarithms. So a common logarithm is a log with base 10. Whenever your log has a base 10, we don't write the base 10. So whenever you see whenever you see a logarithm that doesn't have a base, you have to assume that the base is 10. So it says evaluating common logarithms with the calculator. First thing we do is we're going to do the first one, log of 10,000. We're going to do it without a calculator. So log of 10,000. Well, they don't write it, but there's an imaginary base 10. So I'm trying to figure out, what does this equal? All right, what is log base 10 of 10,000? So then I ask myself, well, 10 raised to what power gives me a 10,000 back? All right, well, since the base is 10, you just count the number of zeros, x equals 4. And that's it. So that's how you would do it without a calculator. I'm going to show you when to check it using our calculator. So log of 10,000. So functions, so when you hit miscellaneous, notice you see just a log by itself. That's common log. So 10,000, all right, it's 4. Then they ask us to find, so they want us to use a calculator. So log of 341. So again, log 341. So that would be the decimal 2.533 if I round it to 3 decimal places. So this one, 2.533. And then we have log of 0.06894. If I remember correctly. So that is a negative number, negative 1.165. So if I round it, .894, it's approximately negative 1.65. All right, so using my calculator. Then you have natural log. Right, so natural log looks like this. You don't even see the word log. We write it as ln. ln of x represents the exponent to which e must be raised in order to obtain x. So natural logarithms, whenever you see ln, that's really log base e of x. So instead of us writing log base e of x, we just write ln of x. So the first one I can do without a calculator. So over here, natural log of e to the 4th. Remember, this is the same thing as log base e, and then you have e to the 4th. You remember that property that we talked about earlier, whenever you have the bases are the same. So notice here, e and e are the same. So they cancel each other out, and what you have left with is 4. So natural log of e to the 4 is just 4. All right, and then we're going to put these other two in our calculator. I'm going to check the first one, and then we'll use our calculator to get the other two. So I have ln, so go to functions. There's an ln button of e to the 4th. So go to my calculator, e, and e is being raised to the 4th power. There you go. Then they asked me to find, using the same numbers, going to do natural log, this time of 341. So 5.832. And then the last one is natural log of that same decimal that we used before. Oops, let me delete this. All right, so natural log of the 0.0684. All right, so negative 2.682 if you're rounding to 3 decimal places. All right, and that's it.